Okay, for problem number 3 on the homework, we are multiplying exponents and dividing exponents, but I like to do it by expansion. So this one is multiplication because of that dot right there, but because you have a negative exponent, that means this is going to go to the bottom. So you have to draw a line so that you can expand some on the top, some on the bottom. When you bring this one to the bottom, it becomes a positive, so you just have one in. Cross it out because you did it already. The rest of them, you do them at the top. So this 2 can go in the front. And then you have 3 sets of parentheses to the power of 3. So you're going to put 1 parenthesis, 2 parentheses, 3 parentheses. And you have n to the third in each one. So then you expand again, because I need to cancel some things out. I have 2 at the top. I have 3 n's right here. N, n, n. I have 3 more, and then 3 more. And then I have this bottom n that I can go ahead and cancel. So that leaves you with a 2 and 8 n's at the top. So the answer is 2n to the 8th power. All right, so now let's go ahead and do problem number 4, which is pretty easy. All you need to do is expand because there's nothing that's going to go to the bottom. None of these have negative exponents, so you're going to do 2 sets of parentheses for the 2v. And then you're going to put 2v times 2 and 2 v's, because this one says that you have 2 v's. Go ahead and multiply all the coefficients. So that's 2 times 2, that's 4 times 2 is 8. And how many v's do you have in total? 1, 2, 3, 4. So that's v to the 4th power. There was nothing different about this one. There was no negative exponents. There was no division. There was no zeros. So it was just straight to the point. Problem number 5. Let's move it down. Problem number 5. There's a lot to expand on this one. And the first thing you need to know is that there is a negative exponent. So that x to the negative 3rd power is going to go to the top. So we just expand it again. So I have, you can multiply, you can do 2 times 2 times 4 is 8, times 3 is 24. You can do that right now and put the 24 in the front. You can also put the 3 at the bottom. Okay, and when you move this x to the negative 3rd to the top, you just say that you have x to the power of a positive 3. Then you also have this x square. Then you have this other x square. And you also have this x by itself. So how many x's do you have? You have 3. 2 more is 5. 2 more is 7. And 1 more is 8. So you have 8 x's at the top. The y's, you have 4 y's here, 4 y's here. So I would put y to the 4th power, y to the 4th power, and then you have y squared at the bottom. Okay, so now that you know where everything goes, I would expand one more time and just write out all the x's. So I would just make a really big line and say that you have 24 on top, you have 3 on bottom, you have 3 x's, then you have another 2 x's, then you have another 2 x's, and 1 x. And your y's, you have 4 y's on top, and another 4 on top, and 2 on bottom. So then you start canceling things. I can cancel 2 y's, and I can also divide 24 by 3. So I would put 24 divided by 3 is 8. And you have 1, 2, 3, 4, 5, 6, 7, 8 x's on the top. And you have 1, 2, 3, 4, 5, 6 y's on the top. So the answer for this one would just be 8x to the 8th power, y to the 6th. Problem number 21. Okay, you're going to have to expand a few times for this one as well. So the first thing that I would expand is this whole thing is to the negative 4 power. So you would bring it to the bottom and make it 4 times itself. So that's 2p, let me write it smaller, 2p m to the negative 1 q to the 0 power, 2p m to the negative 1 q to the 0 power, 2p m to the negative 1 q to the 0 power, 2p m to the negative 1 q to the 0 power. And I would cancel that one out because I'm done with it. I also need to move down m to the power of 1. And I need to keep these at the bottom. So put the 2 in the front. Put the p, q squared at the end. At the top, you end up with 2p to the 3rd power, and you guys can finish off the rest.